So in this question we're going to do the Laplace transformation of this trigonometric function. Now in the previous videos this was my setup for my Laplace transformation. So the Laplace function symbol, which is this L, and the function inside the bracket, that's our Laplace place value, and then equals the limit as a approaches infinity of this integral from 0 to a, hence the infinity. So this is just the unilateral version of the Laplace transformation as it's set from 0. And then we've got this integrand here, e to the minus st f of t, and with respect to t. T is usually a function of time, and s is our parameter. Now our parameter, you see here, I've set that to be greater than 0, which is really important, because if that was 0, this would just reduce to 1. And if s was less than 0, this integral would diverge off to infinity. So we want this to converge to make this work. Okay, now our function here is k times sine wt, where w and k are both integers, and sine is our function, our trig function, and wt is the input. So we can go straight into our Laplace transformation and input this information into it. So let's just do that. So the Laplace of f of t, which is k, times sine of wt, so that's our input, equals the limit as a approaches infinity of the integral from 0 to a, e to the minus st, and our function, which is this. So I'm going to write my function in here first. So I'll write my trig functions and then my exponential function written after it. So let's just do that. K times sine wt, and then e to the minus st, all with respect to t. So that's a nice setup there. Now to integrate this, ideally you want to get this k out, so we don't have to just bring it outside of the integral, we can also bring it outside of the limit. So let's just do that. So just bring this k out of here and just write it there as part of my setup. So that's fine. So now we've got integration by parts set up here. Sine wt e to the minus st. Now integration by parts is u dv, so that would represent this. And then we've got uv minus the integral again of v du. Now in this question here I've got 0 to a as my parameters, so I could just put them in there just to save any confusion. So now I need to decide which I want for my sine, and which my sine is going to be. Is it u or dv? Well, I've got u, u and du, so I'll only need to differentiate my sine. So I'm going to choose that first. So u equals sine wt. Now while I'm here I might as well differentiate it. So to differentiate sine, it's reasonably straightforward. Cosine wt, and then with the chain rule bring the w out front. So that takes care of that. So now my dv will have to be my e to the minus st. So dv equals e to the minus st. So there's no dv on this side, I've only got a v. So there and there. So therefore I need to integrate this. So when integrating the exponential function, the input stays the same, and then we put in our denominator the derivative of minus st. So then I've got minus s, which I'm now going to put like that. So that's how we do our setup for our integration by parts. So now what I'm going to do is, just to try and simplify things, I'm just going to look at this part of the question for now. Because integration by parts of this is going to be something where we just need to keep on our toes a little bit, and then I'm going to find the limit as a approaches infinity and multiply by k at the very end. So now I'm going to bring this over to here. So now I've got from 0 to a sine wt e to the minus st dt. That's my integral, which I've set up here with my u and my dv. That's here. Now my answer is uv. This uv will also need to be calculated over the range of integration, so 0 to a. So let's put my uv in here. So that's these top two terms. So now I've got sine of wt divided by this. So I've got my minus sign, e to the minus st over s. So that takes care of that. And that's from 0 to a. Okay, so now I've got a new integral, which is this v du, which I subtract. So 0 to a, v and du, that's going to be these two. So I've got a minus sign again and a w. So let's put that one there. I've got an s here and then cosine e to the minus st. So I'm going to divide my w by s. So that's just going to make a constant multiple as far as integration is concerned, because we're with respect to t. And then I've got cosine wt e to the minus st dt. Right, so now I could just do a little bit of tidy up while I'm here actually. I've got two minus signs, so I can take them out and just leave this as positive. And my ws I can bring out, leaving with another integration by parts. So w over s, and then let's take this ws out the integrand and just leave it like that. Okay, so now another integration by parts question. I've got cosine wt e to the minus st. Very similar to this. So now I'm going to do integration by parts again. This time I'm going to do my u and du separate, and my dv and v will stay the same because I've got e to the minus st minus e to the minus st. So I just need a new version of u, which is cosine. So now I'm going to go u equals cosine wt. My du will be, differentiate this one, I'll get negative sine wt, and don't forget the chain rule, multiply by w. So now I'm going to put this here as minus w sine wt. So now I've got this, so now I just need to do integration by parts on this one and then multiply the whole thing by s. So let's do the setup on that. So now I've got equals minus sine wt e to the minus st all over s from 0 to a plus w over s. Now this integral here will all be multiplied by ws. So all of my integration by parts will be multiplied by ws. So a nice big brackets here. And then I'm going to have uv. So my new uv is this one. So let's write that one there. So I've got minus cosine wt e to the minus st. So let's do that. So minus cosine wt e to the minus st over s. So that's part of my answer. Again, that will all still be multiplied by this. And then I've got my new integral, which is this one. Again, still affected by this ws here. 0 to a v du. So this one and this one. So I've got two minuses, so I can leave that as a positive inside the integrand. And I've got a w and an s. So I'll leave w and s again in here, which I can bring out there. So let's just do that right from the get-go. So minus w over s, that will take care of that. And e to the minus st sine wt. E to the minus st sine wt dt. So let's just check, make sure we've got everything in there. The s and the w I've taken out. E to the minus st sine wt dt. Okay, so then put a bracket around that. That's my integration by parts. So my answer here with this integral is another integration by parts. But don't forget here, my question was also the same integral. So here I could put 0 to a sine wt e to the minus st dt. I could somehow factor this out, bring it over this side, and then I can do factor it again on the other side with my integral. So let's just do that. So my ws will be distributed with all of this. So let's write that out underneath. So I've got minus sine wt e to the minus st over s, 0 to a, plus, right, let's just distribute ws with all of this. So I've got ws with this term. Now don't forget I've got an s in the bottom here, so now that's w over s squared. And then I've got a minus cosine of wt e to the minus st. And that's also divided by s, which is taken care of. So that takes care of that one. Now still carrying on with this one. So I now subtract another one. So minus w over s, but I multiply both by ws, so I've got w squared over s squared, and then my integral. So that would take care of that as all one term. So 0 to a, e to the minus st sine wt dt. Okay, so now I'm going to rewrite my integral here, and then now it'll all become clear what we can do when we factor this out. Okay, so if I add this to both sides, that will then bring this over to this side. This will just disappear. Then I'll just be left with this on my right hand side. So let's just do that. So now I've got 0 to a, I'm going to write my e to the minus st sine wt e to the minus st dt. And then I'm going to add this one. So plus w squared over s squared multiplied by my integral 0 to a e to the minus st wt sine. So let's write it this way round so we don't get confused. That takes care of that. Okay, so that equals, so let's look at this. So I've got a minus sign here and a minus sign here. Why don't I take this minus sign out the front? So I've got minus, and I've got e to the minus st in both terms as well. So let's put minus e to the minus st, bring that out front. And then I'll have sine wt over s. And then here I'll have positive w over s squared, and then cosine wt, because my minus sign will already be out front. So cosine of wt. That will close off my integral there. Okay, now that's where we're up to so far on our integration. Let's bring that up top, and then let's see if we can find our solution with our limit put in as well. So let's do that next. Okay, so there's our integral there, all almost completed up on the board there. We've just got this little bit here just to tidy up. So if we factor out the integral as the question, which was in this part, we can then get something we can divide by both sides and hopefully find our solution. So let's just take the two terms with the integral, that's on our left hand side, so all of this. So that's what we're interested in at the moment. Let's factor out the integral. So now we get 0 to a sine of wt e to the minus st dt, and then put a bracket in there and multiply by something to the equivalent of that. Well, if that's our integral, that bit here just becomes 1, because that's all we have there. Here we've got the integral and multiplied by this, so plus w squared over s squared. So that takes care of all of that, and then we can just plug in this bit on this side. So minus e to the minus st sine wt over s plus w over s squared cosine wt from 0 to a. Okay, now we've got here now a term where we just divide by this on both sides. So now what we do is we just divide here by 1 plus w squared over s squared. Now if we're just a little bit cunning here, instead of dividing by this 1 plus w squared over s squared, we get it ready for when we go over here. Well, 1, we can just write that as s squared over s squared. which then leaves us with just s squared plus w squared over s squared. So let's just do that on this side, write it in that form, because that's going to help us. So s squared plus w squared, all divided by just the s squared. So that simplifies this side. Now those three terms here are all equivalent. So that's fully legit. So that takes care of that. And then that means that these will cancel out because they're the same. And then we left this as the answer to our integral calculated from the range of parameters from 0 to a. So therefore we're well on the way now to finding our result. So I'll just take this bit here off the board, because that just becomes 1. So our answer to our original integral here is now this. But we want the limit multiplied by k. So I'm going to write this down here now with just this limit inside. So this integral now I can take off because that's my answer. And I'm just looking for now k times the limit as a approaches infinity. Okay, let's work out the limit as a approaches infinity. So as a approaches infinity, that's our integrand parameter, which is t. So basically this is just as t approaches infinity. So that's how we can calculate the result of this. So let's work that out. So as t approaches infinity, minus e to the minus st, that just approaches 0, because negative infinity, that's going to go off to 0. And all of this will not matter because this term will be 0. So that will just disappear at infinity. So what about at 0? Well, we've got this term here. We've got minus e to the minus st, which is just minus e to the 0, which just becomes minus 1. So at 0, this term just becomes minus 1. So we've got k times, we've got 0 at infinity, and then we subtract our minus 1 result and then multiply it by this in here. So sine of 0 is 0. So that term just becomes 0. Cosine of 0 is 1. So we're just left with w over s squared. So now we've got w over s squared. And then all of this will be divided by this term here. So now we've got s squared plus w squared over s squared. And that all becomes in there. Okay, now it looks a little bit confusing. I'm going to take this up to the top of the board. I'm going to work out what our solution is. Okay, now this looks a little bit messy, but that's the result for our Laplace integral. So our Laplace transform of, let's just write that as our function k times sine of wt. That equals, now this, if we can tidy it up, well, we could bring this s squared up to the top and use the minus sign here to turn into a positive sign. So now we've got k times, let's bring this one up to the top and then bring this one to the bottom of that one. So now we can get this simplified out. So we've got s squared w divided by s squared times s squared plus w squared. Now we can simplify that up quite a lot because these s squareds are going to just cancel out. So therefore our general formula for our Laplace transform of this function here is w over s squared plus w squared. So that's our Laplace transform of k times sine wt. Now a couple of examples of what this could be. We could have the Laplace of 3 times the sine of 2t. K will be 3, so that will go with the top. So we'll have a 3 on the top. Our w would be 2, so that's 3 times 2, and that will be divided by s squared, That's our parameter, that's going to stay. And our w squared, which is our 2, so that will then be plus 2 squared, which then equals 6 over s squared plus 4. That will be our Laplace transform for this one. Now what about another example? Let's do the Laplace transform of 4 times sine of just t. So this one will give us, using our formula here, k is 4, multiplied by w, which is just 1, so that just stays as that. And then we'd have an s squared, and then w squared is just 1, so it now just becomes s squared plus 1. That will be our Laplace transformation of those two terms, giving us this for both examples. And this is our general formula for our Laplace transformation. Okay.